All right, so welcome to our session about Oracle workloads running on-prem and in VMware Cloud and AWS. My name is Amanda Blevins. I'm a chief technologist in the office of the CTO. And my co-presenter today?
My name is Sudhir. Good morning. I'm a staff solution architect. I specialize in Oracle technologies.
So I'm a generalist and an infrastructure person, and I have my DBA friends, so we're going to talk about our respective areas of expertise and really pulled together as to how VMware solutions across our portfolio enable running Oracle workloads in the best possible way. So you've seen this disclaimer before. Won't spend any time on that. Since we have 90 minutes today, we have a jam-packed session. And of course, we will make time for questions at the end during the session time and also afterwards. So first off, Sudhir is going to talk about the characteristics of business-critical apps. I'll give you that.
Oh, thank you. See, typically when we use the word BCA or business-critical application, right, it does not really relate to Oracle or the SQLs or the Java or the big data. It's any application in my definition that actually puts food on the table here. And any of these business-critical applications or any of this mission-critical application essentially has a lot of stringent requirements, right? A couple of them could be, high availability, you have performance, recoverability, scalability, security, right, and so on and so forth. The first question that one would ask yourself is, why do you really want to virtualize the business-critical application, Oracle in particular here? So the reason is vSphere essentially throws a blanket around all of the hardware resources so that it is able to abstract them and make sure that it makes efficient use of these resources. Second, you get enhanced availability. One of the use cases, if you were to run Oracle RAC on vSphere HA, you get application level HA on top of infrastructure level HA. And imagine if you were to stretch that cluster across metro distance, now add to it the site level high availability. So right now you have 3 levels of high availability. If one were to run an extended Oracle RAC across metro distance across 2 sites. And of course, you have the fact that you're able to rapidly provision, you're able to rapidly scale. Scaling up here could be hot adding CPU. If let's say the load increases, hot adding memory if the load increases. If one is running the Oracle workloads on a vSAN cluster, if one has to increase compute, if one has to increase storage, one would simply go ahead and add servers with internal drives and low presto. The compute and the storage aspect of the entire cluster increases. Some of the other benefits of running Oracle workloads on SDDC, I am not going to go through this slide as well. I'm going to come up here. See, there's a reason why we put this slide together, right? When we started in the ESXi 1 days, right, essentially, we were small, we started small. But now we are actually running, accelerating with leaps and bounds. In fact, with 6.5, there are a lot of new features for business-critical applications. Just because I put the ones in red doesn't mean the ones in black is not important, right? Because the ones in red are the ones that we will be focusing in today's discussion. Essentially, persistent memory, where one would just stand up and ask, persistent in memory, really that doesn't make sense because memory is volatile, right? And how come you say memory is non-volatile? That's what we'll talk about. With persistent memory, the fact that you're able to use para-virtualized RDMA drivers within your virtual machine, one of the use cases, accelerating an Oracle RAC interconnect. That could be one. HPC, that's another use case. Third use case, if you have database sharding. Fourth use case, if you have Oracle RMAN backing up your database to a media server. Fifth use case, if you have OLTP loading data onto your data warehousing. So I could just go on and on with all of these features up here, right? The fact that you can use virtual NVMe adapters, 4 of them, 15 NVMe devices per adapter, right? And one of the biggest achievements that we did was we actually cut the umbilical cord between cores per socket and virtual NUMA, right? All along before 6.5 is to say, set your cores per socket to 1. If you were to set it to anything apart from 1, right, you would be presenting a different physical NUMA than what your actual physical NUMA looks like. After 6.5, we said, people tend to make a lot of mistakes. We learned from the field. We said, even though you were to set your cores per socket to any other number apart from the default 1, vSphere will intelligently understand what that physical NUMA architecture is and present the right NUMA topology to your virtual machine. And NUMA is important because essentially if you go to the market to buy NUMA servers, our recommendation, don't treat a NUMA server as a UMA, as a uniform memory allocation. It's a NUMA server. Treat it as a NUMA server. 6.7, same. We have VMXNet 3 version 4, persistent memory, and I'll touch a bit about VPMem disk and VPMem. The fact that you have 1 gig huge pages, I mean, Oracle is still not there, but we have 1 gig huge pages to protect guest operating systems. Some of the common objections to virtualizing Oracle workload, and this is a disclaimer I should have probably said when we started up. No talking about Oracle licensing, and I'll probably lie to you guys and break my promise. At the end of the session, if I do have time, I'll take a couple of questions on licensing. But there are a lot of Oracle licensing sessions. Highly encourage you guys to go talk to them. There are panel discussions. But this is essentially streamlining Oracle workloads from on-premises to the cloud. All right. So once we get beyond the characteristics of business-critical application, let's see how we can go about deploying these stringent Oracle workloads, with stringent requirements on VMware SDDC. See, there's a reason why step number 1 is read the documentation. There's a reason why we wrote these documentations, right? These are lessons learned from the field, right? These are real-world examples or real-world lessons that we learned from the field here, right? Then what one would do is one would deploy the workloads in production with all of the best practices. Well, do I need to put in best practices? You don't need to put in best practices. Stuff works right out of the gate, right? You set up a virtual machine, you set up an Oracle database, stuff works. Did you want that workload to perform as you would want it to perform? Probably not. That's the reason why you need to put in best practices. And once you put in best practices and you know that you will be able to scale up, scale out, you'll be able to run your workload optimally, you start accelerating it using the vSphere 6.7 new features, namely persistent memory, RDMA, and all the other features that I spoke about 30 seconds ago. And at some point of time, when you're ready for the cloud, you would migrate your workload to the cloud and back, right? And we'll speak a bit about that as well. Some links, and you guys will get this slide at the after VMworld. You will be able to download the slide and links and so on and so forth. Let's take 30 seconds and look at the design methodology here. Essentially, right, one starts off with all the requirement gathering, right? And at some point of time, you do have to sell the project to the stakeholder. You want people to buy in, right? You want buy-in from people. Sell the project to stakeholders. You need to understand your current environment constraints, because if you don't know what your constraints are, how are you going to scale up? And at some point of time, we need to measure the workload, right? And why is workload measurement so important? The reason why workload measurement is so important, it's not just for migration. It's also for telling your CXS, your DXS as to what is my current workload, right? If somebody were to walk to an Oracle DB and say, what is the current IOPS your Oracle database is pushing? That Oracle DB, me example, in this case, I can't say I don't know. I have to say, you know what, let me look at the AWR report, or let me look at some report, and let me come back to you and say, this is the CPU utilization, memory utilization, this is how much my Oracle rack interconnect is pushing. This is my IOPS. Why? Because I need to scale up, I need to scale out, I need capacity planning, so on and so forth. That's why workload measurement is so critical. And once you measure the workload, you design a vSphere cluster, put in all the best practices, you migrate the data, whether the data is from a little Indian system, essentially x86, or from a big Indian system, the AIXS of the world, the HPUX of the world, the Solaris of the world, right? And once you do that using Oracle methodology and your data lands in the vSphere cluster, now you start putting stuff in. You start putting stuff for backup and recovery. You start putting the covers for high availability. You start putting the covers in for disaster recovery, monitoring and tuning. So nothing here. There is no line item here that stands out and say, hey, look at me, I'm special, right? This is something special that you have to do for VMware. So design methodology, right, of Oracle workloads on vSphere is exactly the same as one would do when you run Oracle workloads on bare metal. I'm going to skip over this, and I'm going to come up here. See, typically, as my role in VMware, right, I do both pre-sales and post-sales. So I talk to customers, I give them advice. I'm also part of a SWAT team that I walk into a customer shop and say, hey, if stuff is not running, this is what you need to do. You need to push these throttles and levers to get stuff to work, right? And many a times I see customers, they come in up and saying, you know what, I say, on my physical environment, I had 24 CPUs, and hence in my virtual environment, I require 24 vCPUs. Now, where did he come up with that kind of math, I'll tell you, right? Did he do any kind of workload sizing? One use case that I see up in the left, and especially I call that garbage in, garbage out, right? This is actually garbage in, garbage out, right? There is no optimization, there is no consolidation, especially you just pick everything up, you move it from point A to point B. One use case, well, I'm getting booted out of my data center in 1 month, I have no time, I would love to do this, but I have no time, I'm just gonna move as is. 6 months down the line, 3 months down the line, when everything stabilizes, I'm going to use VROps, or I'm going to use some kind of monitoring tools, right? And I'm going to see, okay, this is oversized. Let me start cutting the fat here, right? Well, that's one use case. But what we typically tell customers, what we recommend customers is, if you do have the essence of time, please take some time, do workload sizing. Because that way what happens, you save a lot of hardware gear, right? You save a lot of compute. Especially in the Oracle world, when I use the word compute, it's directly proportional to Oracle licensing. Now, why would you go and buy so many servers with so many cores, compute cores, especially, and then scale back once you have paid the Oracle beast so much money for Oracle licensing, right? So that's an important aspect here. Did you want to?
Yeah, I can jump into that. So in the last couple of years, in addition to improving the capabilities of vSphere from a performance standpoint, we've also focused on ease of use, ease of deployment, and adding in security. So one of the things that I'd like to highlight up here is something called App Defense. Let's see if I can use this. OK, great. So VMware App Defense, if you haven't heard about that yet, it's a technology where we proactively review what processes are running on a virtual machine. And so we have a database of all the information that we've collected from App Defense deployed in multiple environments, in tools like Carbon Black, which might explain that acquisition a bit for you, QRadar, other endpoint scanning tools. And we will identify what best practices look like. So then we'll also know, if these 10 processes are running on your virtual machine, we know that that's what it looks like in your environment. If the 11th process shows up, and this isn't something that we've seen before, or it's something that's in the database that is a known bad, we will proactively let you know. And then you have the opportunity to end that process. You have the opportunity to quarantine that virtual machine with something like NSX, so you can review it. You can just kill the virtual machine if it's something scary. And so this is good for a couple of reasons. One, when new Trojans or viruses come out in the world, generally, we're not prepared for those. And so this way, you don't have to have your antivirus, definition files updated right away. This is a way to prevent, intrusion in your network. And my favorite use case is when developers push things to production without telling you. Or, new applications just randomly show up. Well, hey, this is a great way to stop that too. So now we're going to jump into what we call the software-defined data center. And so this will be a crash course in almost every product related to the software-defined data center that VMware has, and then also how this translates to what we do in VMware Cloud and AWS, and by extension, our partnership with Cloud Simple and other clouds like Azure, or running in Google Cloud Platform, or our partners like IBM, CenturyLink, and the other 6,000 cloud providers around the world that run our stack. So for the software-defined data center, we're going to talk about the logical components. And of course, virtualization needs hardware to run. So that does mean that we need servers and networking and storage and compute and memory and things like that. But really, what's very important is that we need to virtualize compute, we need to virtualize storage, and we need to virtualize network and security. And so you might say, well, I'm comfortable with virtualizing compute, but I'm not quite sure about the storage, or maybe you have moved to something like vSAN. And then virtualizing network and security is generally a bit more work intensive and convincing intensive, right, to get your network and security folks on board. In addition to that, we need to make sure that we have monitoring and alerting, and also be able to do analytics on our logs. And this isn't just for the virtualized components or your cloud components. This includes all of your applications and databases and user experience that are applications and functions running on top of your virtualized infrastructure or your cloud. And the layer above that is about your cloud management platform. This includes your automation, your orchestration, bringing in all the scripts you might have written before, and having that one process, that one tool, that overall umbrella that allows you to coordinate that and monitor that to make sure that you can deploy from end to end without any human intervention. And then we also need to make sure that we protect the workloads. And so we'll talk about that from the standpoint of the technologies that VMware provides, and also what that looks like specifically in Oracle environments. So our first step is going to be compute virtualization. I think most everybody here is familiar with these technologies within vSphere, but they each have a different point. So HA is if my hardware fails, I'm going to bring a virtual machine online on another server that's available in that cluster. I can set up rules around which machine comes up first. So of course, I want to make sure my database servers come up before my app servers, before my web servers, right? vMotion, I think, is the best thing since sliced bread. And this is what really excited me about, I think ESX 2.1 was my first exposure to the technology as a customer. And this just allows you to make sure that your workloads are online all the time, regardless if you're moving within your data center, across your own data centers, or up to the public cloud. DRS, distributed resource scheduling, make sure that you're using the components, your compute, your network, your storage, to the best layout and equality across your clusters. It also ties into some of the other tools that I'll talk about later, like vRealize operations. And then fault tolerance, funny enough, because this is an Oracle talk, I remember when fault tolerance came out with vSphere 4. And at the time, I was a technical architect at a company responsible for compute, storage, virtualization. And there were 4 technical architects on the team, one for network and security, me, one for applications, and one for databases, mainly with an Oracle background. And so I was very excited about FT because, well, then we didn't have to do anything special. We just check the box and we make sure that we have 2 versions of the same virtual machine running on 2 different servers. So again, this was like 10 years ago, right? vSphere 4, beta version. And so my Oracle architect was very, just didn't think it was going to work, right? Just didn't think it was going to be valid. And so he did the test through performance, and he was pleasantly surprised that it met his performance expectations around the physical. And so again, this was 10 years ago. So imagine using FT now for Oracle workloads. And we talk a bit about the different options and the maximums. What's very important is that we have multiple guides online at VMware. We have the configs maximum guide. You never have to memorize it. We always update it for each version. We also have a compatibility guide. So if you are putting your own environment together, you know what version of vSphere is compatible with what version NSX or Site Recovery Manager, what VROps supports, etc. Would you like to talk about some PMEM?
Yes, thank you. All right, so essentially, right, if you look at the top of the pyramid here, right, the characteristics for the top of the pyramid is low latency, right? So start looking from the top of the pyramid. You have CPU, and then you have the cache lines, right? Then you have the DRAM, right, the DRAM. And then at some point of time, you have the flash SSD. That could either be a slow or a fast one. And at some point of time, you have magnetic HSDs, right? CPU, probably less than 1 nanosecond, right? Cache, 1 to 10 nanoseconds. DRAM, it goes in the order of nanoseconds. Once you start talking to flash, whether it's fast or slow, it's millisecond, right? Sorry, it's microsecond. And then once you come down to disk, magnetic HDD, that's milliseconds. And once you go to tape, it's seconds. But if you start looking at the characteristics here, memory is volatile. So if the power goes off, everything goes off, right? You have to read everything back into cache here, right? Unfortunately, with memory, what you get is low latency, right? If you start looking at any of the block store data, the flash or the magnetic HSD, right, what you have is non-volatility. So you have data persistence. Problem, you have high latency. So the ask here is, can I marry 2 other characteristics here? Low latency with data persistence. Low latency with data persistence, and that's what persistent memory is. Essentially, if you look at the persistent memory, whether it's Micron making it, whether it's HP making it, whether it's Intel 3D Crosspoint is a bit different, right? What they have is they have a DIMM, right? So they have the DRAM, the DIMM, and on the DIMM, what they have is they have a flash SSD, and they also have a capacitor. So anytime the power goes off on the server, what happens is the capacitor has enough charge to copy data or copy buffers from DRAM onto the flash SSD. And when the power comes back on, it does just the vice versa. It's just the reverse. Copy stuff from flash SSD back to the buffers. So think of it. You were here where you were when the power went off, right? So what are the use cases? In-memory databases, use cases, Oracle databases, so on and so forth, right? Now the question is, how can you address it? You can address it in 2 ways. It can either be byte addressable, or it can be block addressable. So when you say byte addressable, it's load store. Block addressable, you have to use the SCSI commands, right? Whether it's read or write, and if you use async IO, it's pread and prewrite, right? So you have 2 ways of using it, byte or block. Again, next question to ask yourself, oh, that's great, right? I have a persistent memory, I have a DIMM in the ESXi server. How can my virtual machine consume it? One of the two ways. I spoke about two, right? Block and byte. You can present that persistent memory, right? You can present the PMEM. When I use the word PMEM, I refer to persistent memory. So when you present that persistent memory or PMM as a block device, you can encompass or you can enclose it within a data store. So you can create a data store on top of that. And then what happens? You can now create VMDKs on top of that data store. What's the use case here? Legacy applications. See, this is not particular to databases. That can apply to anything. Legacy applications. For example, you had an old Oracle 10G environment, right? That's desupported, that's deprecated. Your Oracle DBA just threw the bat in the stand and you just left the company. Right? Now, life still has to go on. Business still has to go on, right? And I need to still nurture the database and I still need to accelerate the database. But I don't know any of the DBA tricks. How would I do that? Simply by moving the VMDK, or if the database is so small, move the entire database to the PMM data store. Simply by moving the redo log file over to the PMM data store, simply by doing that, you are able to accelerate the redo log file. And by accelerating the redo log file, you are able to accelerate the Oracle database. Guess why? The redo log is the bottleneck for an Oracle database. Pretty much for any database, any RDBMS, right? Unless you don't write to the redo log file, unless the redo log file, the LGWR, doesn't come back and say, I got it, you cannot move forward, right? So that is the bottleneck. So that's one of the ways you can accelerate an Oracle database. The other way, modern operating systems. For example, RHEL 7.3, RHEL 7.4, right? Or even SUSE. You can use or you can create an NVDIMM. You can create a virtual NVDIMM controller and a virtual NVDIMM adapter within a virtual machine, and you can consume it within the virtual machine and the guest operating system, both as block and byte, right? One of the use cases there, mount it as DAX option, mounted with the DAX option. DAX stands for direct access. By doing that, it's again byte addressable. Right? Essentially, all of these mechanisms, all of the methods that I'm talking about here is to accelerate Oracle workloads, right? Again, it's not specific to Oracle workloads. SAP could use that, SQL could use that, SQL and Linux could use that. If you have Java, you could use that, right? So, but the use case here is Oracle databases. So I did the session on Monday. Hopefully, once you guys get the slides, go through that. It has far more details into how we went through that. The use cases we did with persistent memory, like I mentioned a couple of seconds ago, read log activity. So we were able to improve the overall database performance. Second, Oracle database smart flash. So you know what? Probably I should have asked this question before. So how many here are like well versed with the Oracle technology? To a certain. Oh, good. All right. So here's the thing, right? When I say smart flash, think of it. You have the Oracle SGA, right? So Oracle reads everything from disk, puts it in RAM, and we call that the SGA. The SGA stands for the shared global area, right? Buffer cache or the Oracle database smart flash, think of it as a tier 2 cache. If anything slides down the SGA because it is on the LRU list, right? Least recently used list, it actually slides down, it goes back, it gets written to the disk, right? And next time you have to read it back again, you have to read it back from the disk. I'm oversimplifying this entire operation here. What if I were to put a tier 2 cache here? Right, and say, you know what, instead of going back to the disk, why don't you just go back here? And then if I have to read it back, I'll read it back from another, the tier 2 flash. That's what the smart flash is. So accelerating performance of smart flash. Third, there is a potential reduction in Oracle licensing, and I'll take 15 seconds and tell you what. We had a virtual machine, 12 vCPUs. I was able to run the workload, and I got X. Simply by moving the redo log files of that Oracle database onto either vPMM disk, right, block, or either vPMM, byte addressable, I was able to run the same workload with 9 vCPUs. See, if I can get that performance, or if I can run the same workload with lesser number of vCPUs, and I do it across the board, right? I do it across the board for the entire Oracle landscape. What does that tell you? I don't need to have that many number of cores for my vSphere cluster that sustains the Oracle workload. And if I don't need to have that many number of cores, that is directly proportional to the Oracle Enterprise Edition licensing, right? I'm not saying you'll be able to cut your Oracle licensing by half or 60% or 80%. It depends upon the workload. See, any metrics that you get from a workload is a function of so many parameters. The hardware, the software, the test bed, the data density, the data distribution. It's not just ones and zeros, right? What do you have? Do you have floating point? Do you have integers? So there are so many characteristics of a database. So based on your workload that you guys are running, you definitely might be able to get some kind of potential reduction in Oracle licensing. So all of that is there in this white paper. So you know what? There are a lot of AWR metrics for people who really want to get down, down and dirty with the Oracle metrics. It's there. You want to do this?
Yeah, we can go ahead and do that. So really, the idea, in addition to Oracle and all applications, is that we want to make sure that one, we have access to the resources that we need in the best way possible. So sometimes that means using the entire virtualized stack to be able to address hardware, and sometimes that means that we need to be able to pass through to the hardware directly. So this has been available inside vSphere for many releases, but what's also important is that you can also vMotion when you use para-virtualized devices.
Right, and adding to that, right, so especially what happens is when you have a virtual machine, right, and when you come up with, and we always recommend, use VMX Net3 when you use network adapter cards, right, virtual network adapter cards, because it's network adapter with rocket fuel, with rocket boost, right, so it increases performance. Same thing goes when you have SCSI controllers. Please use PV SCSI controllers. Why? There's a reason why. It's low CPU utilization, high bandwidth, high throughput, so on and so forth, right? With PV RDMA, what happens is it's the same network interface, VMX Net3, excepting it also has the RDMA verbs in that, right? So what's the use case for PV RDMA here? Let's look at it. Oracle RAC, that's one of the use cases here. So let's just quickly take 30 seconds to look at this one. When we don't have RDS, so look at the left side, right? Typically in an Oracle world, right, the Oracle database will talk to IPC in the user space, right? There are two context areas, the user space and the kernel space. So Oracle talks to IPC in the user space, and in the kernel space, it talks to UDP, right? I mean, before 11 some version, right, for clusterware, it used to use TCP. After 11 dot something, it started using TCP UDP for both clusterware and RDPMS, right? So IPC in the user space talks to UDP in the kernel space, and then it can talk to any of these hardware, whether it's an HCA or whether it's a NIC up here, right? The beauty is Oracle and QLogic at some couple of years ago, they worked and they came up with an IPC protocol. It's actually a socket protocol called RDS, Remote Datagram Socket. Remote Datagram Socket, right? That is characterized by low overhead. So it's got very low overhead, very low latency, and high bandwidth, right? One of the ways you guys can find it is if you were to go to your alert log file, right, for your 11G database, for your 12C database, just look at the alert log file for the Oracle database. It will say IPC LW. IPC lightweight. So the database, the clusterware, everything uses IPC by default. By default, it uses that. The clusterware uses UDP. The Oracle database uses IPC. So what's the advantage of using RDS? Low overhead, low latency, high bandwidth. So what happens is your CPU cycles, it frees up CPU cycles for application processing, for the much needed application processing. The other thing is it's agnostic to RDMA. It does not care what kind of RDMA device is there. So it can either work with ROCE, ROCE, right? RDMA over Converged Ethernet, or even with an InfiniBand HCA. So one can link the Oracle RDBMS and the grid infrastructure libraries to RDS, right? And you can run ROCE, you can run RDMA over Converged Ethernet, right? And let's look at it. The traffic basically flows, right? IPC talks to RDS, it just goes to the HCA. Essentially, and I'm not an RDMA expert here, but essentially the way it works is the user space memory buffers, right? That gets registered with the HCA. The user space memory buffers get registered with the HCA, and when the other virtual machine or the other physical server makes a call out, it knows exactly where to go and grab it from. It doesn't have to go and tell the kernel, hey kernel, go get it from the user space. The user space says, okay, here you go. Take this buffer. Okay, thank you. Then it sends it up here. So all this handshaking, this back and forth, it reduces. So it's a zero offload. Right? It's a zero copy, zero offload. It saves a lot of cycles on the operating system. Again, so one of the tests we did was this. What we did was first a 40 gigabit Mellanox card, right? That was a 27500 Connect X3, right? That was only used for the Oracle RAC interconnect. My use case was use the default UDP, right? Set up a default UDP, run it, and see what do I get. That was baseline number one. Next, link the Oracle libraries with RDS, right? Run RDS over RDMA, right? ROCE, right? Run that, and then get the stats out, and let's compare it. See, don't get put off by these numbers here, because my workload was a synthetic workload. right? My workload was a synthetic workload, was a very small workload. For my synthetic small workload that I ran, if I'm able to get substantial benefit for what I ran, I'm sure when you guys go back, your workload is much different, right? You guys run much bigger and better workload than what I run in my little lab around here. But I was able to see a lot of improvement when we used RDS with PB-RDMA over Mellanox RDMA, right? And essentially, if I have to break this down, it's not just the throughput increase, right, from an interconnect perspective. It's basically the whole thing. See, if you talk to an Oracle DB and say, okay, what are the different characteristics or what are the different metrics you look at that tells you that the workload performance has increased? One, the number of SQLs that you can execute in a second, right? The workload characterization, whether it's good or bad, is characterized by the number of SQLs I can do in a second. How much work can I do within that time? That SQLs per second increased from this number to this number here. My number of transactions increased from this number to this number. My wait times, and wait times are very important, right? Remember when you start tuning Oracle database, or for that matter, any other real-time application, right? You have to start looking at the wait time. How can I reduce my wait time, right? So that my response time becomes faster and faster. So I was able to get increase in interconnect, increase in IOPS, increase in throughput. And again, what was that? So we had a session on Monday where we spoke about this as well. Again, this will be available to you guys, right after VMworld, you can download this session. I'll quickly finish up with 1 gigabit huge page. So 1 gigabyte huge page. So we came up with the 1 gigabyte huge page for the Oracle workloads, not specifically for Oracle workloads, 1 gigabyte huge page. Let me ask you, how many guys have heard about huge pages? Right. Why do you need huge pages? What advantages that huge page gives you? Swapping, right? See, the best part is ESXi has its own flavor of huge pages, and ESXi does not care if the guest operating system uses huge pages or not, right? ESXi says, I will protect you. I will use huge pages, 2 megabyte, and I will protect the guest operating system. But within the guest operating system, if you have your 2 megabyte huge page set up, it's a win-win situation, right? Huge page up here on the ESXi level, huge page up here on the guest operating system level, right? It's a win-win situation here. It reduces your swappiness, right? So we came up with the 1 gigabyte huge page for any workload. I mean, Oracle is not particular in this, but these are the steps that you would do in order to make sure that you can use the 1 gigabyte huge page. Yeah, unfortunately with Oracle needs to catch up, right? It's been lagging behind in a lot of technological areas. Yeah, unfortunately with Oracle, we are not able to use that. Reason being, when Oracle boots up, when Oracle comes up, right, there is something what's called a fixed SGA. There's a little area called fixed SGA, and that is hard-coded to use 2 megabyte, right? And how did I know that? I did an S-trace. I did an octal dump. I did an S-trace, and I said, okay, let me trace it. Let me see what exactly does it do. And it does a call out and says, you know what, I'm so sorry, I can't use it. This is what it is, right? So there's a blog post. You guys can go and look at the entire S-trace. And then there are areas where I've marked saying, sorry, can't use it, right? But in a nutshell, we are there, right? In a nutshell, we have para-virtualized RDMA drivers. We have persistent memory. We have 1 gigabyte huge page. Well, Oracle, you need to keep calm and catch up. But let me turn this over to Amanda here.
I'll jump into machine learning. So we won't get deep into this technology, but I do want to stress the importance of using specialized hardware such as GPUs, FPGAs when you are doing machine learning. Basically with machine learning, you want to take a bunch of data, like they call it big data sets, so not small, not medium sized, but big data sets, and you're using statistical models to understand what is probably true. And so in machine learning, the algorithm decides what is the probability of this thing being true or this thing matching to it. And so that, of course, image classification, is this a cat, is this not a cat, right? That seems to be like the most common use case for ML out there. But also, things like we use it in healthcare to be able to identify illness or issues within a human heart, for example. What is the stock market doing, or how should I be trading? And also inside VMware, we use it in many ways to understand how your infrastructure is performing, how your applications are performing. And to give you an example of how important GPUs are to high performance of machine learning workloads is initially you need to create this machine learning model. And the machine learning model is what will become the inference engine that will do the work in production. But before you get a model or an inference engine into production, you need to create it and train it. And then you need to determine after it's trained if it's actually smart enough or good enough to go into production. Usually the first time it is not. So that means that you have to manually label data. So machine learning is actually like not fun at all. It's like all this tedious work of labeling data and labeling more data and saying, these are the parameters or the variables that I want you to identify upon, and this is what good looks like. Try and learn that across all these data sets and then see how you do with a new data set. So I was on a team, I was leading a team where we were building a machine learning model. And in our environment, we did not have access to a GPU. And so our data set was, I don't know, hundreds of thousands of lines of information, not that big, I guess not huge data. And it would take us over a week to train the model in this virtual environment without a GPU. So of course, that really damaged our productivity because we would make all these changes to this model that we were trying to improve, and then we have to wait a week and see how we did. So then we gained access to an environment with a virtualized GPU, just one. And so we went from over a week to train our model to 11 hours. So that's why it's very important to have GPU hardware available in your environment for your data scientists and where you're going with machine learning. You know, often we talk about machine learning or VDI by day and machine learning by night. So if you have users that are doing graphic-intensive use cases like CAD or something like that, you'll have these folks online in their virtual desktops doing their job, and then at night, they're probably sleeping, and maybe you don't have folks around the world using it, so now you have idle hardware. So that is the perfect time for you to be able to train your models when you have those GPUs lying around, just not doing anything. You might have heard of our acquisition of Bitfusion that closed just recently. And Bitfusion is very cool from the standpoint that you do not need to have the GPU in the server that you are running the virtual machine. The GPU can be in a different physical server, in a different vSphere cluster, and you can access that GPU over the network. And what I find even more cool is that, when you build a virtual machine, you need to tell it what virtual hardware it's connected to, right? You have to choose those settings or update the VMX file, whatever that looks like. When you use Bitfusion, because it's addressed over the network, you do not need to configure the virtual machine to attach to the GPU at any time. That's not part of the VM hardware settings. So when you are going to run your machine learning model or train your model, you just run it with a command to connect to the GPU. So this way, it's very easy to enable a virtual machine to be able to train or run machine learning models without having to reconfigure the hardware. You're also able to, like we talked about the para-virtualized work, virtual GPUs or partially virtualized GPUs in the environment. And we talked, Sudhir talked a lot about CPU utilization and making sure that you right-size your CPUs for your Oracle workload and how it benefits your licensing. But one key takeaway that I hope that you remember is, basically ESXi, well, we do a lot of things, but basically we're a scheduler of these workloads. And there are multiple virtual machines and many cores in the box. So the smaller amount of cores that we need to schedule, the more performant your workload will be. So remember that. That's why, yes, we want to make sure that we have less expensive licensing, but in any workload, you want to right-size it to make sure you're using the least amount of cores possible because it's way easier to schedule 4 cores than it is to schedule 32 cores, right? So if you have trouble speaking to your DBA and application friends and convincing them that they need to have less resources, just point out that logic to them and maybe they will agree and let you size down those virtual machines that they think need to be huge. So now we're going to jump into storage.
Sorry, go back.
Want to say one more thing?
Yeah. So the previous slide. So one of the use cases that I can think of, Oracle with GPU, right, is big data. Or even huge data warehousing databases. See, all along a couple of years ago, we used to have databases, data warehousing databases. The primary reason was, there were a lot of reasons. One of the reasons was business intelligence, right? Data flowing from data warehouses to data mart, people consuming data mart, coming up with all these reports. What we have seen of late, right, probably a couple of years ago was operational intelligence along with business intelligence, right? The question is, okay, for example, Mother's Day. Now, how many flowers did I sell last year, right? Or how many gifts did I sell last year? And how many do you think I'm going to sell this year, right? And then combine that with operational intelligence. How much hardware did I have to push in order for me to sustain that website, or in order for me to sustain that hardware that actually enabled all the customers to go in, log in, and buy the stuff and ship. So operational intelligence with business intelligence, right? That's one of the use cases where I can see GPU can help, especially with huge customers, right? I don't know, with Amazon during Mother's Day, Valentine's Day, and so on and so forth. But yeah.
Very good.
Yeah.
So now we're going to jump into the virtualized storage aspect. And VMware, we've had a technology called vSAN for a long time. SAN is a storage area network, which usually means that you have to spend millions of dollars on a monolithic array and determine what your storage architecture will look like before you even buy a shelf of disks. So you have the best performance across the shelf of disks and the disks that are available within that array. So that gets very expensive to initially purchase, very expensive to scale properly if you're going to do it based on performance rather than just capacity. Also, traditionally, when you bought those ESXi hosts before, you're like, oh, I need a drive or two to load the ESXi hypervisor, but that's all I need. So now I have all these empty drive bays in my servers. So vSAN gives you the ability to add drives to your servers and build a virtualized SAN across all those hosts. So instead of having to get the fiber channel cards and go and talk to your fiber channel network and configure that and make sure that you do all your zoning and things like that, it's more of a go into vCenter, check a couple boxes, enable vSAN, tell us what your risk comfort level is, how many copies of files that you want, and then we will configure that SAN for you. And then you can just consume it as a normal data store as you would have in the past. So then say that you need more storage, more shared storage across your SAN, and you can't ask your boss for another $1 million to get another storage array, but it's very easy to ask him for a few $1,000s to say, hey, I need another server with disk. So this way you can expand your compute in the cluster and you can expand your storage at that time. So you can either add drives into those empty bays, or you can add more hosts, and that vSAN data store will recognize that you have more hosts, add it to that cluster, and span that across the environment. So it's the software-defined data center is not only about virtualizing everything and automating everything and have better visibility into what you're doing, but it's also about changing operational silos. So as an infrastructure person, I mainly focus on servers and storage. And of course, when I did that, I had to have specialized training for storage. And I was the only person that knew how to create these disks and manage the HBAs and zone out the paths that I needed. And so most of my time was dedicated to managing the storage environment. Well, now when you get to the point where it's click a couple buttons and decide your risk level, well, you don't need a whole person for that anymore. So when we move into hyperconverged infrastructure, when we virtualize more components, it means that we're removing the complexity from the environment, and that also means that we all have the opportunity to be able to do more in our lives. So instead of just being a compute person or just a network person or just a storage person, now I get to learn all the components of the environment. And a nice little joke, if you ever want to sound like you know stuff about storage, you can say disks do 3 things. They read, they write, and they fail. And now you're a storage admin. Go ahead.
All right. So this is the solution history when we first started developing Oracle collaterals on VMware HCI, vSAN, right? So we started off at 2015. So at some point of time, we started coming up with extended Oracle rack clusters, traditional rack clusters on vSAN, followed by running Oracle database workloads, very high IO-intensive workloads on 6.2 vSAN, day 2 operations, and then of course the 6.7 is already released. I have to update the slide here. It's not coming soon. It's already out there. So yeah, if you look at this diagram here, right? See, for any Oracle rack installation, be that Oracle on a physical architecture, Oracle on vSphere, there are 2 tenets or 2 key principles for running an Oracle rack. One is shared storage, second shared networking, right? When you run Oracle rack on VMware, be that a classic ESXi connected to a SAN or a NAS, or vSAN, or VxRack, or VxRail, or even VMware Cloud on AWS, right? These 2 key tenets, shared storage and shared networking, is provided right out of the gate. You don't have to run a third-party product, right? For example, I'll give you an example here. When one wants to run Oracle RAC on Amazon EC2, you can't just do it out of the gate because there is no concept of shared storage. So one would have to run a software called FlashGrid on top of Amazon EC2 in order to run Oracle RAC. So a software on top of a software, and I don't know what kind of performance you guys will get out of that, right? With vSphere, the shared storage capability, the shared networking capability is embedded right into the vSphere kernel. So you don't have to do anything auto-magic. You don't have to do anything magic to make that thing happen, right? With RAC, and of course, probably everybody understands what RAC cluster is, right? You have a virtual machine. Let's take an example of a 2-node Oracle RAC. You have a virtual machine, let's say VM1, virtual machine VM2. These two virtual machines, they share the same devices. That magic of making the device shared among these two virtual machines is done by using what's called a multi-writer flag. It's a multi-writer flag, which means many people or many virtual machines can write simultaneously to the same VMDK. And that's done using the multi-writer capability and the fact that the VMDKs have to be eager zero thick, right? So that's important. The KB article for that on ESXi is 1034165. On vSAN is 2121181, right? But coming back to here, so this is a 3-site example. So first what we did was, okay, can we run an Oracle RAC on a vSAN cluster, right? So we had a 4-node vSAN cluster, a 4-node ESXi server. Every ESXi server had 2 disk groups. Every disk group had 1 800 gig for cache and 5 for capacity, so 1.2. Yes, this was the older vSAN 6.1 hybrid. So we started with the hybrid model. The version of Oracle was 11.204. I understand 11.204 is kind of deprecated, but that's how we started with, right? We said, okay, fine. Can we come up with a couple of use cases? My use cases was vSAN resiliency, shut a host down, see what happens. Take a disk group offline, see what happens. Take a disk offline, see what happens. Let's fail the listener. Let's fail the Oracle clusterware. Let's fail. So we went gaga over this one, right? Let's test every component of this architecture and see, is it really resilience, right? It's there in that white paper as well. So all of the test cases are documented. We found, yes, we got very good performance out of that as well. And then we said, okay, fine. Now that we conquered the traditional Oracle RAC on a vSAN cluster, can we achieve resiliency across sites? So we stretched the vSAN cluster across metro distance, right? So essentially we had site A, that's the primary site. We had site B, that's another site. And then we had the site C, which was a witness site, right? There's site A, site B, and site C. And then basically we put our Oracle RAC. And okay, what does extended Oracle RAC actually gives you? It gives you all of the capabilities that a traditional Oracle RAC gives you, excepting it's across metro distance, right? It's stretched across 2 sites. So key thing, your shared storage and your shared networking has to be stretched across both the sites, right? What does that give you? Workload balancing, right? Workload mobility, workload failover. So if I have to take one site down, if I have to do something to this one site, failover thing up here, right? Do what you have to do on this site. Well, bring the site back up, fail everything back here, do what you have to do on this site, and low presto, everything is up and running, right? And then, sorry, go back. And then at some point of time, we said, okay, can we now inculcate backup and recovery? Can we now inculcate, standby or disaster recovery to this architecture here as well? We did that. So you guys can read that in the white paper. Next. Right. We spoke about running, Oracle 12c data warehousing on vSAN All Flash 6.7. Actually, we started with 6.2, and then we upgraded this architecture for 6.7. So we did a lot of tests, right? So we had, again, a 4-node vSAN cluster, right? We had 2 virtual machines, 2 genres of virtual machine, a medium and a high, right? A medium and a big. And we said, can we run both these virtual machines? So 2 virtual machines on each server, and then can we slam dunk it with like slob? Can we just hit it with slob and see, can I bring vSAN to my knees? Am I able to get that kind of optimal performance that I think I should get from this vSAN cluster, right? Again, here, every ESXi server had 2 disk groups. Each disk group had 1 cache and 3 capacity, all SSDs, 800 gig SSDs, right? For the old TP workload, we use slob. How many people have heard of slob? SLOB. Good. Silly little Oracle benchmark, right? Written by Kevin Claassen. He's a great guy. Right? The guy wrote the Oracle ODM, Oracle Disk Manager, right? So essentially, when one uses synthetic workloads like Swing Bench, you're able to tax the CPU, you're able to tax the memory, and also the Oracle interconnect. Storage, not that much. Right? With slob, you can either go one of the 2 ways. You can do CPU, memory, disk, and interconnect. You can do everything that you want to slob. So we use slob. We tried to emulate a real world workload, 75% read, 25% write, RAID 1. We got very good numbers. Then we said, okay, fine, let's switch gears and let's use DSS, right? So Swing Bench sales history, 100% read, IO throughput, we did not turn off any of the vSAN features, right? Dedupe, compression, checksum. We didn't do any of that erasure coding. We didn't do that. Because typically, when I talk to a couple of the customers, they say, hey, you know what? Should I turn off checksum? No. Should I turn off erasure coding? No. Should I turn off dedupe and compression? Don't do that, right? Yes, make sure that you account for that, right? Because nobody in his real mind, his or her real mind, will ever run any ESXi cluster to 99.9999%, right? You will definitely make sure you have enough headroom, right, for admission control, so on and so forth. So these doesn't take much CPU cycles, right? So please don't turn off any other features. Again, for the sake of time, I'm going to move forward, but again, all of that is documented in the paper that you guys can read. Next. So we said, you know what, now that we did the Oracle rack, we did the data guard, we did the RMAN, right? We did everything, right? Traditional, extended, so on and so forth. We did, you know, the throughput, the high I/O throughput tuning, right? Can we also do day 2 operations? Because what happens is, if you look at a DBA's life, right? 10% of what he or she does is actual installation configuration. 90% of what they do is day 2 operations. Oh, backup, cloning, let me do database refresh. This is what I used to do for so many years, 24 years, before I came to VMware, right? Can you clone a database for me? Can you back up a database for me? Can you do a restore for me? Can you restore a table? I want to do database refresh. I want to do database patching. So can we do all of that? Not going out to the market and buying any expensive tools, but just using what native tools ESXi gives to me. So basically what we did, I use RMAN, we use the database begin, backup, and end, simple tools that Oracle provides right out of the gate with vSphere native features. And we were able to achieve that as well. So next slide. For example, right? Well, we had to do a backup and recovery on vSAN because I had to clone something. So the first step, set the database in a begin backup mode, take a snapshot, do an end backup mode, right? From the snapshot, clone a virtual machine, great. Now start the virtual machine up, the cloned virtual machine. Once it comes up, it won't come up automatically because it still requires media recovery. What you would then do is then you would go ahead, do media recovery. Once you do media recovery, alter database until cancel or checkpoint or SCN or whatever you guys want to do. Once you're done, bring the database up, low presto. This is a copy of your production database. Now do what you want to do with that, right? I did not use any third-party tool. All I did was essentially using SQL commands, native vSphere commands. So again, vSAN is no different, right? You can do that on vSphere, you can do that on vSAN, VMware Cloud on AWS, pretty much every VMware offering. Probably can skip over this as well. So we covered this one. So you'll be getting these slides. Cool.
Okay. So now we're going to jump into our offerings around network and security and virtualization. And so really our approach at VMware is to make sure that you have the same technology and the same operational model, whether it's in your own data center, whether you're leveraging our technology in somebody else's cloud, or at the edge. And this also is true for virtual machines and containers. I will not say Kubernetes anymore in this presentation in case you're tired of hearing about it this week. So we won't be talking about that. But really what the virtual cloud networking is about is an entire portfolio around our NSX platform, which is our virtualized network and security. So I did talk about app defense before, but I do want to point out that we have NSX offerings for within your data center. We also have it for public cloud providers. So if you choose to run workloads in native AWS, native Azure, native GCP, you can use the same technology to create logical networks and logical security rules. In addition to that, we've made acquisitions around having SD-WAN. And so our VeloCloud solution is the most used solution for SD-WAN in the world. And then also you saw an HCX demo yesterday on main stage where we vMotioned an AWS workload into Azure and Azure workload into AWS. And basically, you do not necessarily need to own NSX to be able to take advantage of the HCX technology to move to the public cloud. In addition to that, once we virtualize network and security, now it is a lot easier to automate, and it's a lot easier to have introspection in that area. So the reason I say it's a lot easier to automate is, say you have Cisco gear in your data center, and then you decide, oh, I want Arista, or I want Juniper. Well, all those scripts and the configuration files that you wrote for Cisco are useless in your Juniper environment. So now you need to learn a whole new set of skills, learn a new operating system, learn to automate the Juniper, and the same with Arista. And all of a sudden you want to go to public cloud. All right, well, they don't have Cisco, right? AWS is not providing access to Arista. Same thing with Azure and GCP. So now, all of a sudden, you have multiple operational models and technologies on-prem. Even if you do acquisitions, if you say I'm Cisco forever, maybe you acquire a company and they are not. So the idea is that if you virtualize everything, then you have a single set of APIs and a single set of constructs and logical access to be able to automate your network and security configuration across whatever hardware you choose, just like with compute virtualization. So the vRealize automation platform is what we offer to be able to do that automation CI/CD across your entire environment. And when we say that, it's not just deploy a virtual machine, it's not just deploy a database. We can automate the entire deployment of an application, including register in your CMDB, update your firewall rules, update your load balancer information, add monitoring, do backup and disaster recovery, install the application, configure the application, all of that work. And also we have a technology called Network Insight, which will map all application and database traffic across your entire environment, virtual machines, containers, physical, even out to public clouds. So if you're in a situation where nobody knows what applications are talking to other applications, which is probably everyone, this is a great way to provide a real-time map of that. So you can do troubleshooting, so you can understand what your environment looks like. If you need to do data center consolidation or migration of applications to the cloud, this gives you that information. I've met people that have been going through companies that are divesting, and they need to figure out how do I move these workloads over here and which workloads even need to move. So Network Insight provides a lot of abilities to do that. So when it comes to NSX, we'll jump into really what that looks like. And so NSX and vSAN, I probably should have mentioned this with vSAN, they're all built into the vSphere kernel. So basically, to leverage NSX and to leverage vSAN, you're just adding another license key, and then now these features are enabled. And that's important because the performance is basically at bare metal performance. You're not talking out to some virtual machine sidecar and asking it to do all your storage operations. You're not asking it to do all your networking operations. It's something that happens in the kernel. So all of the NSX firewall rules, configurations, load balancers, et cetera, as soon as it leaves that virtual machine, before it even leaves that virtual machine, we are able to say if that firewall rule is valid or not. So a good example of that is if I have a virtual machine that needs to talk to a physical server, another virtual machine over here on this other host, how does that traffic go? It needs to leave the virtual machine, the virtual NIC, into the virtual switch, to the NIC, out to the network, to the top of rack, to an end of road, to the core, to the firewall. Firewall, can I talk, yes or no? All the way back, okay, now you can go. And then it routes it over to the other virtual machine or the other host over here, and it has to take that same path. So, that takes some time, that takes some load on my network. If I have the firewall rules loaded within my kernel on the virtual machine, as soon as it goes from the from the vNIC to the vSwitch, I can determine that, and I don't have to leave and do anything else. The other benefit to NSX is that you create something called VXLANs, which are virtual LANs, which is weird because VLANs are virtual. But the ability of VXLANs means that, therefore, you could have the same IP addresses everywhere in your data center. It's okay. We can NAT that. The other nice thing about VXLANs is we can take that VXLAN and move it wherever you want. So if it's time to do disaster recovery, what's the worst part of disaster recovery? Changing IPs. Because people never hide that in random configuration files in their applications. They're always easy to find and easily reference. So this way you can do disaster recovery without changing any of your IP addresses because the VXLANs can be moved across layer 2 or layer 3 and still be available. Same thing with moving your workloads to something like VMware Cloud and AWS or our offerings in Azure, GCP, and all the other cloud providers I mentioned. So I talked a bit about Network Insight. I do want to build out this slide so you can see the power of it. And also we have, as most of the things I'll be talking about today, we have an on-prem version. So if you like to have appliances in your data center and manage them or have compliance or regulatory requirements, you can run that on-prem, manage it yourself. It's kind of like VROps. You install the appliance, you tell it to talk to something, you go have lunch or have a cup of coffee, and then you come back and you're like, look, my entire environment's mapped for me. If you don't want to install appliance, we also have a SaaS offering. Well, I guess you'll have to install appliance to collect data, but you will not have to manage the technology itself because we host that for you. So then there's this concept of microsegmentation. And microsegmentation gives you finer and granular security for each of your applications. And so usually there's like a web server VLAN and an app server VLAN and a database VLAN, and every machine that does one of those things is on that VLAN, or maybe you have a couple, who knows. But really you have 200 servers, virtualized or other, that can speak to each other. So if you have a web DMZ VLAN and you have 40 web servers out there, when do those web servers need to talk to each other? I don't know. Not Petya, right? Like any type of Trojan where you want to have Windows be able to talk to each other to replicate. So if you had a physical firewall and you didn't want a server on the same VLAN to talk to the other server on the VLAN, how many rules do you have to create in your firewall? And how easy is that to manage? Well, it's like operationally impossible. With something like NSX, with NSX in particular, because we are within the kernel, because that firewall rule doesn't even need to leave the virtual switch, and we create rules based on constructs other than IPs, if you so wish, such as names or data center organizations or tags within the VMs, to be able to prevent this virtual machine from talking to this other virtual machine in the same VLAN is a single rule. It's just one. So your operations are far easier with NSX, and you have a lot more introspection around what's happening in your environment. So there's a really cool demo on main stage by my friend Marcos yesterday, where he showed this new solution called NSX Intelligence, where you can go through, we will map out what an application looks like. We will tell you all the opportunities for microsegmentation, so it doesn't have to talk to anything it doesn't need to. It can be moved to a VXLAN. And then you are able to simulate what that looks like and see if you're comfortable with what the firewall rule changes look like before you implement that. And since we are going to talk about moving to VMware Cloud and AWS, it is very important to have a tool just like Network Insight to be able to see what are the laws of physics going to restrict me in doing, right? So if you do have databases or applications that you cannot move to the public cloud, well, you need to know that, like from a regulatory compliance, personal preference, organizational rules. And then you want to say, well, I do want to deploy this new application in the public cloud or in the hybrid cloud that's not my data center. Is that even possible? Is it possible from a performance perspective? Is it possible from a cost perspective? And so that way you want to make sure that you really know what's talking across the network. And so one of the things that Sudhir talked about was the concept of a metro cluster with vSAN, where you could have this extended vSAN, this cluster across 2 different metro environments as long as it met our latency requirements. Well, it's the same thing with NSX. And we talked about the ability of in disaster recovery, where you do not need to change the IP addresses with NSX. So that's really powerful when you need to fail over to another site or move to another site. So now we're going to jump into some of the VMware solutions around data protection and running our workloads in different clouds.
Right. So we spoke about RAC, right? We spoke about extended Oracle RAC, so I'm not going to focus too much time on this, right? The best part is when you run RAC on vSphere, we call that RAC on RAC, HA on HA, high availability on HA, right? So typically when we talk to customers, initially when we first came out with the proposition, they were like, okay, Oracle RAC and VMware HA, right? One these two worlds collide, right? One they impede each other. The answer is no. I mean, they work in 2 different areas, right? So with vSphere HA, like I said before, you have infrastructure level HA. With Oracle RAC, you get app level HA, right? The best part is, Oracle RAC, yes, is absolutely supported on VMware, right? It's just not me, a VMware guy, telling you. It's basically Oracle. So if you go to the Metalink note or the mysupportedoracle.com, 249.212.1, it says Oracle RAC is supported since November 8, 2010. So that was the first time we did our testing with Oracle Corporation. So Oracle and VMware, we worked together to get Oracle RAC certified. That was a 10G installation on vSphere, right?
And the other thing I want to mention, because we keep saying VMware Cloud and AWS, like in addition to vSphere, vSAN, NSX, the reason we do that is because VMware Cloud and AWS and those other cloud offerings is the same exact build. It's the same exact version of vSphere, NSX, and vSAN that you have available to you. So anything that we're talking about on-prem is equally applicable to these workloads in those offerings.
Yeah. And on the same line, the steps for setting the multi-writer flag is exactly the same. So that doesn't change. See, that's the beauty of the whole proposition, right? One doesn't have to go relearn any steps for setting up multi-writer to enable shared devices for an Oracle RAC cluster. Be that it's on ESXi, is it vSAN, is it VxRack, VxRail, or VMware Cloud on AWS. It's exactly the same, right? So again, the KB articles are provided there for both vSAN and for ESXi. So probably can skip over this one. So we spoke about extended rack. This one thing that I wanted to bring out, I won't spend too much time on that, is misconceptions, right? So when you talk about, for example, disaster recovery, when you talk Oracle Data Guard, many people say, oh, when we use Data Guard, it's high availability. No, it's not high availability, right? It's disaster recovery. And when you use Oracle RAC, it's high availability. That's not DR. Think of it, why? Because it's a shared data, right? If there is garbage introduced from one of the instances onto the database, the other instance is going to read garbage, so that's it. Right? It's not disaster recovery. So HA is HA and DR is DR and never the twain shall meet, right? So that's Oracle RAC. This is Oracle, Data Guard or Active Data Guard or whatever you have, right? Or a Golden Gate. So probably we can go skip on this one. So the reason why I came up with this was, yes, there are two ways you can have storage virtualization, either host-based or appliance-based, right? When the host-based, for example, ASM, when you use Oracle ASM to do that mirroring, what happens is you're sucking cycles out of CPU, right? You're sucking CPU cycles to do the actual hardware mirroring. ASM does that. So in which case, there's a bit of a penalty up there, right? The pros to that is, well, it's bundled with Oracle, well, it's easy to set up, it's storage agnostic. Both methods, whether it's host-based or whether it's appliance-based, they require a third site for voting disk. There are some special ASM configuration needs that need to be set up. That's there on the bottom of the slide. Right. So let's start looking at the appliance way of doing stuff, right? So we have an offering called vSphere Metro Storage Cluster, right? Essentially, it provides synchronous replication with any array-based clustering, right? That could be, some of the products could be EMC vPlex, could be HPPO persistence, could be NetApp Metro Cluster, or even IBM SVC, right? And I'm sure you guys have definitely heard of that. It's typically used in the Metro, the campus-based data center, right? The key thing here is disaster avoidance. Well, I need to have site level high availability along with infra level and along with the app level. And that's the reason why this product is there. So the thing to keep in mind, right, with Oracle RAC, right, is, there's a 5 millisecond RTT. When you talk about Oracle RAC, they say 5 millisecond RTT. That doesn't change whether it's a traditional Oracle RAC or whether there's an extended Oracle RAC across metro distance. So make sure that your 5 millisecond RTT is set, right? Again, that 5 millisecond RTT, right, technically speaking, it's not embedded in the kernel. It's basically best practices saying, don't get it across 5 millisecond RTT, especially to do with the speed of light, so on and so forth. So up to 50 kilometers, it's stable, right? Up to 100, well, stuff can work. Beyond 100, it's a real stretch. You know what, don't even try that. So that's what we say. That's an example for running extended Oracle RAC on VMC using vPlex, right? Same thing, you need another third site for the witness for vPlex. And then, quickly. So what happens is on both the sides, you have virtual volumes, right? So they present the vPlex or the VMSC presents virtual volume, and that is synchronously replicated across the vPlex interconnect. So I don't have enough time to go through that, but anyways, there's a KB article that tells you exactly how to set that up.
So in addition to the concept of metro clusters and using things like storage, vMotion, extended volumes to protect your environments, we also have a solution called Site Recovery Manager that's been around for a very long time. And if you don't use it, definitely do that. Because who has successful DR events and successful DR tests? Right, no one. No one does. Oh, a couple. Maybe because they use SRM? Yeah. So Site Recovery Manager is an agnostic tool where you do not need to rely on the protection technology of individual applications and databases. So if you don't want to set up an Oracle rack, if you don't want to set up SQL Marion, if you don't want to set up applications that are state aware and you know, spread across sites, well, now we have the ability to create an orchestration workflow of virtual machines that need to be protected in certain groups and then can be recovered on the other side. So we can use vSphere-based replication, which is just built into ESXi. We can use storage-based replication with the storage partners that we have adapters for. And basically what we do is we say, protect these virtual machines, put them in groups, and then we say, bring them up in this order on the other side. And so just like HA, you want to make sure that you have, you know, your base services online, like Active Directory, DNS, et cetera. And then, of course, your databases come online first. So this is something that can tie into the capabilities that exist in Oracle technologies, too.
Right. So quickly touching on that, the Oracle Data Guide is the one that actually does the replication. SRM doesn't do that. SRM is just a workflow generator. It's a workflow, right? But the beauty of it is, well, somebody has to be there on the other end to run certain SQL scripts in order to transform the database from a standby to the primary, right? Think of it, if you had 1,000 databases and all these 1,000 production databases had standby, the poor SQL guy or the poor DBA would have to go run the same script 1,000 times to do that while you have your CIO or CEO breathing down on your neck and saying, you know what, is everything up, is everything up? We need to get business going. So as part of that, what we did was, as part of the post-power on process of any virtual machine, right, on the DR side, what one can do is one can embed this little script that basically says, alter database, commit to switch over to primary. Just change my mode from standby to primary, right? And once you do that, that same SQL script, it's a simple SQL script. Same SQL script can be run on every Oracle standby database, in which case the Oracle DBA doesn't have to go and start typing the commands or even, you know, doing an SSH and running this command. So this is more for simplicity. Again, keep in mind, SRM does not do the replication for the Oracle database. It's the Oracle Data Guide that does that, but this is giving a bit of ease and giving a bit of life back to the Oracle DBAs and saying, you know what, in event of disaster recovery, you could use that and, you know, ease the automation of your DR. And that's exactly that's the example for that one. Let's get that one. Yeah.
And I already talked about FT and the technology to be able to run the same copy of a virtual machine on a different host, so it takes over immediately, and that is compatible with the Site Recovery Manager technologies. So now we need to jump into monitoring and log analytics. So our take of operations at VMware is that we have the marketing term self-driving operations. But really what this means is we want to make operations as easy as possible on you to be able to identify what normal is and only alert you when something is out of bounds, when something is doing something that is abnormal in your environment. So a good example of this is, say, you usually have a CPU, a vCPU, that runs at 75%. Well, if you had a traditional monitoring tool, you might say, alert me if a vCPU runs above 70%. So that means you're getting an alert like every 5 minutes that's routed to a folder in your Outlook that you never check, right? But really, what's important is if that vCPU utilization drops from 75% down to 25%, you're like, oh, something's happening there. And so those are the types of things that we want to bring to the surface. So we have something called vRealize automation, vRealize operations. And vRealize operations we do a lot. We talk about optimizing the performance. So again, we're using the right number of CPUs and memory is important for cost, but also actual performance. We do capacity analysis to understand how you're using your environment and when you will need to add things like storage, compute, et cetera. And then, of course, we have the alerts, but we also integrate our log analytics into this. So generally, something goes wrong when something changed. When I used to work the help desk, somebody would call and say, this is broken. I'd say, what did you do right before you called me, right? Yep. So this way, we have the logs available of your operating systems, of your applications, of your databases, and we can correlate that with performance changes in your environment. And we also want to make sure that your environment is compliant in the way that you set. So this way, you know, we have all those abilities in a single pane of glass. And we can also map these applications and map the virtual machines to an application database architecture. So you have the correlation of you know, your environment. And then also you can set up your own dashboards to be able to manage this yourself. So we talked about the what-if analysis, and that's also important when you're going to do migration planning. So that way we've built this in to say, if you're running something in this configuration on-prem, What does this look like if I am going to run it in a different cloud? And that also helps you determine what your costs would be. So we have a technology called Skyline. Who's heard of that? Good, a good number of you. So Skyline is something that's available to you where you install an appliance in your environment and it talks to vCenter and pulls information about your environment. And that way, we at VMware can provide proactive support. So if we notice something is configured incorrectly, if you are generating certain log alerts, we can reach out to you and say, hey, this is wrong. How about you fix it before you have an outage? And so we also integrate that into Virtualized Operations. The other thing that I want to point out before we jump into the Oracle-specific stuff is that Virtualized Operations is not just VMware alerting or VMware information. We can take in any set of information from any SQL time series database. So if you have other monitoring tools in your environment, if you have infrastructure monitoring tools and from Cisco, Dell, HP, whatever it might be, your network monitoring tools, all of your application information, those monitoring tools can come in and even user experience. So a good example of that is how you can specifically troubleshoot Oracle, but you can also build an entire dashboard from infrastructure to user experience to see exactly where a root cause would be, rather than getting 25 people on the phone and everybody says, oh, it's the network, because it's always the network causing issues. So what does this look like from an Oracle standpoint?
Right, so what happens is when one virtualizes the Oracle databases on ESXi, right? Typically, Oracle DBA say, hey, there's another layer, right? There's an ESXi layer. So how do I make sure that I'm able to see a single pane of glass, right? So I would want to get metrics from the Oracle database, metrics from the operating system, metrics from the virtual machine, the ESXi, the ESXi server, the storage switch, so on and so forth. So it becomes very easy if I have to troubleshoot or if I have to monitor my Oracle databases. And the answer here is VROps. There's another company called Blue Medora. They provide Oracle adapters. So these adapters can either go after an Oracle instance or they can go after the Oracle Enterprise Manager, which basically monitors all the other Oracle database instances in your shop, right? So one has the capability or the ability to extract metrics from whatever user-defined metrics that you guys have, whether it's DB block, sequential read, whether it's scattered read, whether it's log file sync, whether it's CPU utilization, memory utilization, whether it's swapping, whatever you guys have, right? You can extract that, look at it and say, you know what, between 8 to 9 o'clock, when we had this issue today, I don't think it's the database, or probably it could be the database, or I think this issue is here, right? So this is typically what PSO. So when services, when we go in for troubleshooting customers' Oracle database issues, the first thing we ask them is, do you have VROps installed? And if you do, please let me have a look at it and let me start troubleshooting. It's an excellent tool, it's an excellent tool that you can have in your arsenal, especially along with the Blue Medora adapter. So.
Yeah, and then so I talked about integrating your log analytics. So we have a tool called Virtualized Log Insight. And again, both for VROps and Virtualized Log Insight, there is a SaaS version that you can obtain. And just like we provide a lot of content packs around this, you can also get other content packs from our marketplace, and that's available to you. And so our content packs are around, let's do these analytics around the log, do the correlation for you. So it's not just a pretty way to look at your logs. It's a tool that shows you what are the patterns in your log files, what are these analytics, and this ties in directly into vSphere. And so not only is it VMware technology, but you can also bring in your system logs, your application logs, your database logs. So it is fully extensible. When we talk about the automation orchestration layer, I like to put up this chart not because it's very easy to read and teaches you a lot, but I put this up because you can see how many components in your environment that truly need to be automated or truly touched by humans when you look to deploy an application, database, and stack into your environment. And your environment probably contains multiple hypervisors, multiple clouds, OpenStack, OpenShift, other Kubernetes things. Okay, I said it twice. But you need to be able to automate to all of those things with the same tool as opposed to different tools. And so a lot of times I talk to companies where they say, hey, we have a team that is our cloud team, is our DevOps team, and we have 8 people, and we use 15 different open source tools to be able to do this end-to-end deployment. And then I say, well, what about when it changes? What about when AWS changes their API? What about when you move to different hardware? What about when you need to add a new service into your environment? And so this means that they have a team of 8 people just managing a bunch of open source tools to be able to deploy software into their environment. And usually it's not end to end, and usually it's not monitored to make sure that it's successful. So that way we can provide the technology that you need. We take care of the maintenance and the updates, sending APIs. We add new services for you. And again, you can have this on-prem, or we will host it for you, and you can leverage those technologies. And this supports your on-prem environment, your vSphere environment, and other technologies on-prem. And it supports public clouds, whether you're running vSphere up there, or if you're using AWS, native Azure. And so we can also provide specific services. So if you're not trying to automate the entire thing, but you want to give the ability for self-service for your DBAs, you can also automate the deployment of a standalone Oracle environment or an entire rack environment. So this shows you the workflow of all the things that we take care of during this VRA deployment. So VRA is Virtualized Automation, and VRO is Virtualized Orchestrator. So if Virtualized Automation does not have a technology built into it, Virtualized Orchestrator is called to be able to do the rest of the work. And so once you do this in the background and set this up, this is all the user sees, is the self-service catalog that says, hey, do you want to deploy this? And they can enter in a few things that they need, such as IP addresses, what they want to call it. You can also give them the option to select their CPUs and memory, or you can restrict that and not let them select it. Or you can say there is a governance model. If you want 2 CPUs, we'll allow that without any approval. Anything above that, we will need approval. So we talked about all these technologies, and we don't make it easy for you to manage these technologies. The last time you upgraded vSphere from planning to production deployment, how long did it take you to complete your entire environment? Or are you still doing it? Right? It takes months, years, you're still doing it, you're just constantly doing it. So now you say, hey, I want vSAN, hey, I want NSX, I want all these other technologies in my environment, I do want cloud automation, I do want virtualized operations. So that just means for your entire life, you're just upgrading and maintaining our software. So that's, like a huge waste of your time, and you're not able to do the cool stuff. So what we did is we built something called VCF, or Cloud Foundation. And this is an opinionated, engineered design of what vSphere, NSX, and vSAN should look like together. We do all the configuration testing, the performance testing, the integration testing. And so when you decide, hey, I do want to use those technologies, you buy half a rack of servers, up to 8 racks of servers from your favorite hardware vendor, because we provide the BOM to them, what this looks like. We provide the configuration to them. We provide the VCF software to them. And so when it lands in your environment, you just enter things in like passwords, Active Directory information, IP address ranges that you want to consume, and then you click go, and we will deploy the entire stack for you. We will also call out to the lifecycle management of the vRealize suite and deploy that as well. So that's great. Now it's deployed in an hour, but then the new security patches come out. Or you decide you want to upgrade to the next version of vSphere, NSX vSAN. That's fine, because we know exactly what that environment looks like. You don't have to do this manually anymore. You just download a package from us that contains all the software that you need to upgrade, to patch, whatever it might be, and you just deploy that package to the workload domain that you decide is your dev environment. You test it out, and then you deploy it to the next environment. So no longer are you spending months and years of your life managing our software. We do that for you. So I highly recommend at any point, if you move beyond vSphere, or even if you just stay within vSphere, to use Cloud Foundation rather than managing these components independently. And so the reason I talk about Cloud Foundation is because this same Cloud Foundation that you run on-prem or you run at the edge is what we run in the AWS data centers for VMware Cloud and AWS. It's the same technology that IBM uses, or Cloud Simple uses, or VirtuStream uses to host it in Google Compute Platform, or to host it in AWS, or to host it in their cloud environments. So you know that because we are running it, when we find a bug, we're going to fix it immediately, right? And we pass those fixes on to you immediately as well. So all the stuff that we talked about with HA and DR, because it's the underlying technology that is exactly the same with SRM, with vMotion, with Oracle RAC and DataGuard, this all applies to VMware Cloud on AWS, just like it applied to on-prem, except in VMware Cloud and AWS, you don't have to manage anything. We take care of managing vSphere, NSX, vSAN. Amazon takes care of managing the hardware. We have a relationship with them to take care of that. So when you consume VMware Cloud and AWS, you just get a vCenter and you go and do your thing. And so that means that you take just a few steps when you want to migrate to the cloud. It truly is just a vMotion. And it's a vMotion of storage, and it's a vMotion of compute. With technologies like NSX or with HCX, you do not need to change those IP addresses. And it's also the same thing, everything that we talked about for best practices of running RAC, you can also run that in VMware Cloud and AWS. And if you have Direct Connect or other capabilities and the speed is available, you can still do those stretch clusters. Is there anything you want to add?
Yeah, so we have a session today at 11:30 to 12:30 where we will be going deep dive, right? Oracle and SAP use cases on VMware Cloud and AWS, essentially deployment, migration of a single instance, deployment, migration of an Oracle RAC. Vas Mitra, my SAP counterpart, will be talking about how to migrate SAP workloads from on-premise to the cloud. So if you guys are interested, the session is from 11:30 to 12:30, and that's the session number. Right.
Very good. And so we talked about replication. HCX gives you different capabilities. You can do a cold migration. But also you can do a bulk migration. So you can say, I know I'm going to move 1,000 virtual machines up to VMware Cloud and AWS, or to this new environment, or to this new cloud foundation within my data center off the old vSphere environment. And then it will replicate that. And when you are ready to switch over, you say, I'm ready to switch over, and everything is there. So did you want to talk about licensing in our last 4 minutes?
I would probably skip on that, and I'll open it up for question and answers, because I know there are a lot of licensing sessions that you guys can go to where they do an effective job of beating this whole topic to death. Let's not do that in 4 minutes here. Open it up for questions so we can skip all the slides. Yeah. Yes, go ahead.
So, quick question. When you were talking about, I think you called it Rocket for the interconnect between...
Rocky, yes. Yeah.
Do you have to enable jumbo frames, or what's the MQ setting between the nodes?
So the thing is, jumbo frames is recommended, regardless of whether you have Rocky or whether you're not using Rocky, whether it's using InfiniBand or not using InfiniBand. If you have a 10 gigabit network, we say, please enable jumbo frame. But that's not restricted alone to the Oracle RAC interconnect. Your vSAN interconnect, right? Your vSAN, even vMotion traffic, right? We say, if you have a 10 gigabit, just use it. And the other caveat, of course, you guys know it. I'm preaching to the choir here. It's an end-to-end, right? Jumbo frames, want to do it end-to-end, or don't do it at all, right? Because you don't want to miss, you don't want to have a mismatch. Yeah.
So we have a bunch of resources in this deck. I know it's hard to write down URLs and follow them. But the thing about VMware is we have Twitter accounts for every product and team that we have. We release tons of videos on YouTube. We have lots of white papers that we write. We store things on GitHub to make your life easier and have samples. And of course, from the Oracle perspective, there are lots of blogs that have been referenced in this talk. And your presenter up here also likes to write books.
Yes, so if you can go back, so if you can, I mean, this is not very important. What's very important, if there's anything that you have to take away from this session, this is the one slide, right? So anything that you're looking for, any Oracle information on vSphere, right? Whether that's Oracle on VMware, ESXi, vSAN, VxRack, VxRail, Oracle with vVols, Oracle with VRA, VRO, VROps, Oracle on VMware Cloud on AWS, licensing, what should I do, what should I not do, KB articles, pretty much everything. That's the one-stop shop. And essentially, I have some magical cards here. I suck at cards, but these are magical cards here. So you guys can come up and take these cards. These are not my visiting cards, so don't worry. I'm not going to call you guys or make random calls. If you scan these cards, it actually takes you to the one-stop shop. So it's like an easy thing for you guys. I have a couple of stickers left here. I'm not supposed to be giving this out officially, so I'm just going to leave it here, turn my back and pretend I don't know who's going to take these. So that's it. But apart from that, any other questions, please do let me know. But thank you.
And of course, please fill out your surveys. Thank you very much.
Thanks a lot. Thank you.